Okay. Well, as I told you guys, what we are going to be doing today is a continuation of what we did on Thursday and roots and real exponents. Remember that before we began with this lesson, I asked you to please print or at least copy the law of exponents in your notebook. And that's because when you work with rational exponents, you are using the law of exponents that you learned in 8th grade. So I'm going to change my screen so that we can start doing some exercises. Today is March 1st. Very quickly. This year is going fast, very fast. Sorry, I'm going to change the color. 2021. Lesson 0,4. And roots and real exponents. Rational exponents, sorry, not real. Rational exponents. Continuation. So we're gonna write here that is a continuation from last week. Now, question. On Thursday, did we solve this exercise? The one that I'm going to write on the screen right now. Did we solve this exercise? The 8th root of B to the 24th.
Yes. And
Yes. We solved it, right?
yes.
Just give me a moment. I'm just going to do something with my pad here, my tablet, because it's getting like stuck.
Miss, I think the only one we didn't do was letter D.
Mm-hmm.
Okay, okay. But the answer that we wrote is this, right? B to the cube.
Yes.
Okay. Now, based on what you just wrote right now from page P15, the power is even, sorry. This power is an even number, it's 24. And the index, okay, of the root is also even, 8. But the power that you got here is an odd number, 3. So when the index and the power of the radicand are both even numbers, but the result gives you an odd number, you need to write this in between, absolute value. So add the absolute value, okay? Add it to your answer, to the one of Thursday. The next one that we did was the 6th root. I'm sorry, I don't know what is happening with my pad. 64 y plus 2 to the 30. And the answer that we got was 2 y plus 2 to the 5th power. This is an even radicand. It's an even index, but the answer that we got is odd. So that means that we need to write it in absolute value. Okay. 48 x to the power of 5. And here we have 4x squared, square root of 3x. Now, the exponent is even and the index is even. You do not need you do not need the absolute value. Now, you are telling me that we didn't do letter D. So let's do letter D. The cubic root of -27, a to the power of 6, b to the cube, c to the 5th power. Okie dokies. Let's work with this. According to the property of radicals, I can separate the cubic root, because it's a product of negative 27 times the cubic root of a to the 6 times the cubic root of b to the cube times the cubic root of a to the power of 5. Now, use your calculator and tell me what is the cubic root of negative 27.
Is 3.
Positive or negative? 3. Come on, use your calculator, boys and girls. What is the cubic root of negative 27? Well, if you don't tell me,
Negative 3.
aha, negative, negative 3. Now, remember that there is a property for this one. There is the property that tells you that if you have this, you can rewrite it as x b over a. So that means that I can rewrite a 6 divided by 3 times b 3 divided by 3 times, well, in this case, 5 divided by 3 is, I'm going to show you a trick when you have, when the index, when the power inside of the radicand is greater than the index. You are going to divide this power by the index. 5 divided by 3 is 1, right? Yes or no? And 1 times 3 is 3. And the remainder is 2. 1, remainder 2. Pay attention what is going to happen here. I'm going to write this as a cubic root of a to the square. Sorry, it's not an a, it's a c. I don't know why I wrote an a, it's a c. Sorry, I'm going to erase that because this is a c. This is c to the power of 5. And this is a c. Yes, I will correct down here. Is that I saw it as an a.
Me,
It's a c. Tell me
I don't understand.
what I did or anything that I'm doing.
Me too, I didn't understand.
Nothing that I did or just the last part.
You can repeat. I don't know. It's because I don't understand. I get lost.
Okay, I'm going to begin since here. Let's begin again. Okay, everyone is clear until this point. Tell me yes or tell me no. What I did is that I used a property of radicals that tells me that if I have a product, I can separate the product. Each one of the terms inside the radicand that are being that are being multiplied, I can separate them in individual radicals, each with the same index. Until there, are we clear?
Yes.
Okay. Now, I am going to simplify each radical individually. We already know that the cubic root of negative 27 is negative 3. Okay. Now, the property that I am going to use to simplify these radicals, this one and this one, is the property that tells me that I can rewrite the radical as a power with a rational exponent. If I have this, I can rewrite this radical as a power with a rational exponent, b divided by a, b divided by a. So that's what I'm gonna do here. Times a to what power? 6 divided by 3, 6 divided by 3, times b to what power? 3 divided by 3. Okay, until there, are we clear?
Yes.
Yes or no? Okay. Now, I'm going to use a different approach for this one. Instead of doing the division, let's rewrite this c to the power of 5 as c to the cube times c to the square. You know that the property tells me that if I have two products that have the same base, two powers that have the same base, I copy the base and I add the exponents. 3 plus 2 is 5. Until there, are we clear? Yes. Okay, now let's continue simplifying. Negative 3 times a 6 divided by 3 is 2. Do we agree?
Yes, me.
Times b, 3 divided by 3 is 1, right? So I put 1. If I want, I write it, but it's not mandatory. Remember that this is invisible math. Now, in order to leave the radical, the power must be 3. So that means that I can take this c outside. But this little guy right here won't be able to leave the radical because the power is 2, not 3. So you will have to leave it inside the radical, c to the square. Now you can rewrite all of this expression without the dots. Negative 3a square b c cubic root of c square. And I'm done.
Miss, but for C, could we do the same that you did for A and B?
Yes, I can do the same. The problem is that 5 divided by 3 won't give you a whole number, right?
Miss,
Uh-huh.
I have a question. So the absolute value, we have to like add it or
Well, the
no?
absolute value works when you have, listen carefully, when you have a even power and an even index, and the product and the answer that you have, that you get, has an odd power. But in this case, it's 3. It's not even, okay? It's not even. So that's why you don't use the absolute value, because it's the odd of the radicand is even. It's odd, sorry, it's odd. You work with the evens, with the absolute value when both powers are even and the answer that you get is odd. Then you use the absolute value. In this case, the index is 3. 3 is odd. Okay? So you don't have to use the absolute value. Okay, let's do other examples so that we can get this clear. The 4th root of 25 divided by the 6th root of 5. This will be letter E. Now listen. To simplify this expression, I will use this property. Keep this property in mind because this is the one that we're going to be using a lot. I am going to rewrite this radical expression as a power with rational exponents. So I will write this as 25 to the 1/4 divided by 5 to the 1/6. Sorry. Now listen. When you are working with exponents, there is a property that tells you that when you have the quotient of two powers with the same base, you copy the base and you subtract the exponents. Do you remember this property? Well, if you do not remember, write it down. I'm telling it to you right now. When you have the quotient of two powers that have the same base, you copy the base and you subtract the exponents. That is the property. Now, as you can see, 25 and 5 do not have the same base. But I can rewrite 25 as a power with exponent 2. 5 to the square. You already know that 5 to the square is 25. You should know that. To the 1/4 divided by 5 to the 1/6. Why did I do this? Because I need both powers to have the same base. Now, there is another property, and write it down, that this property is known as power of a power. Power of a power. If you have a base to a power and that to another power, you multiply the powers. M times N. That means that you have 5 to the square times 1/4. I can rewrite this as 5. Tell me how much is 2 times 1/4? Please tell me how much is 2 times 1/4? Let's multiply this.
1.5
One
or
half.
0.5.
1/2. Let's not work with decimals, okay? Always work with the rationals. Divided by 5 and 1/6. Notice that now we have the same base, so I can use this property. See? I will copy the base and I will subtract the exponents. 1/2 minus 1/6. Now tell me how much is 1/2 minus 1/6?
1/3 is
1/3. Now I will use this property, this one, to write it as a radical. I have the rational exponent. I will write it as a radical. Sorry, you said 1/3, right? And I wrote 1/2, 1/3. So this will be the cubic root of 5. And you're done. Hold on just a second.
Mute your microphone.
Yes, sorry, my mistake. Okay, let's continue. Okay, let's do another exercise. Letter F. Let's see. The 6th root of x to the power of 31, y to the power of 20. Okay, let me give you another process here. Let me give you another way of doing this that is quicker. Listen carefully. I am going to divide the exponents. 31 and 20, each one of them by the index of the radicand. 31 divided by 6, okay, is how much? How much is 31 divided by 6? Let's see.
5.1.
Okay, but I will want the remainders as whole numbers, not as decimals. That will be 1, right? 5 remainder 1. Keep that word in mind, remainder. Now let's divide 20 divided by 6. And that is 3, right? 3 times 6 is 18, and that gives you 2. 3 remainder 2. Now, if you understand this, everything from now on is going to be very simple. Now pay close attention. I will write, okay, the variable with the quotient that I got. outside. This is the quotient, right? 5 and 3. So I will write the variable with the quotient outside. And what do you think will happen with this 1 and these 2? How do you call them? How do you call this 1 and how do you call these 2?
Remainders.
Remainders. And what comes to your mind when you listen to the word remainder?
They keep inside of the root.
That they remain inside of their root. Very good. X, the remainder is 1, so you just write X. And Y, the remainder is 2, so you put 2. Now, again, pay attention. The index here is 6. The index here is 6. But your answer has an odd number. So that means that you will have to write it in between absolute value bars. The index is 6. It's an even number. But the answer that you got is an odd number. So that means that you will have to write it in between absolute value bars too. So let's write it again. I'm going to write it again. This will be the absolute value of x to the power of 5 times the absolute value of y to the cube. 6 root of xy squared. Making a summary of this, you get the power and you divide it by the index. The quotient is the exponent of the power of the variable that you're going to write outside. And the remainder is the power, of the variable that will have to stay inside. That's why it's called remainder. Okay, the following exercises, you are going to find them on page 17. Sorry. I'm going to erase this. Book page 17. And we're going to work on exercises 17 to 22. Okay, let's work with number 17. B to the 5/4 times B to the 3/4 divided by B to the 1/4. Okay. Basically, this exercise can be solved using the property of exponents. Remember me, because I just wrote it like 10 minutes ago. If you have the product of two powers that have the same base, what are you going to do? I copy this in the note in this. I gave you that.
You're going to copy the base and multiply the exponents.
No, multiply the exponents, no. That is power of a
Divide,
power.
sorry.
No. I copy the base and I add the exponents. So that will be 5/4 plus 3/4 divided by B to the 1/4. So this is, tell me how much is 5/4 plus 3/4?
I got 2.
That's the answer, 2. They have the same base, the same denominator, so you copy the denominator and add the numerators. 5 plus 3 is 8, and 8 divided by 4 is 2. Divided by B to the 1/4. Now, this is a quotient of two powers that have the same base. You just copy the property like 5 minutes ago.
We subtract.
We copy the base and we subtract the exponents. 2 minus 1/4. And how much is 2 minus 1/4? Come on, you have a calculator.
7/4.
Okay, 7/4. this is a rational exponent, I can write it as a radical, okay? Fourth root of b to the 7th power. Okay, number 18. If you don't understand my numbers, you can see them on your book. 2x to the 1/4, y to the 1/3, 3x to the 1/4, y to the 2/3. Okay, so here we are going to be using the multiplication property. The multiplication property tells me that when the same as this one, okay? You copy the base and you add the exponents. 2 times 3 is 6. X, how much is 1/4 plus 1/4? Calculators, 1/4 plus 1/4. You add them.
Well, 1.5. 1, 2.
1/2.
1/2.
And y, how much is 1/3 plus 2/3?
1.
So it's 1, right? That means that you can rewrite this as 6y square root of x. It's the same. Because you already know that any base to the exponent 1/2 is a square root. Okay, number 19. You have the 6th root of 640 a to the cube. Okay, first we need to factor 640 to find out if it has a 6th root. 640 is divisible by 2. That gives you 320. It's divisible by 2, right? 160. It's divisible by 2, and that is 80. By 2, and that gives you 40. By 2, and that gives you 20. By 2, and that is 10. By 2 is 5, and by 5 is 1. So let's see. We can rewrite this as 1, 2, 3, 4, 5, 6. Yes, 2 to the power of 6 times 10, because 2 times 5 is 10, times 10, times a to the cube. Now listen, when the power is less than the index, there's nothing you can do, okay? You cannot take it out. That means that I can rewrite this as 2, because this one can leave, but these 2 will have to stay inside. 6 root of 10 a to the cube. Did you understand? Okay. No one is speaking. That means that everybody understood. I'm going to erase this. Number 20. You have the 6th root of 128 b to the power of 4. So that means that we will have to factor 128 to find out if it has a 6th root. Divided by 2 is 64. Divided by 2 is 32. Divided by 2 will give me 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. And by 2 is 1. 1, 2, 3, 4, 5, 6. 7. So that means that I can rewrite this as 2 to the power of 6 times 2 times b to the power of 4. I can take this one out, and that will be 2 6 root of 2b to the power of 4. Now, number 21. And I think this will be the last one because we don't have much time. You have the cubic root of 16 over the 5th root, right? Is that a 5? That I don't see.
Miss,
Uh-huh.
Yes, it is a 5.
I have a question. Why you don't cancel the 6 of the 2 6 and with the other 6?
Here, I canceled this one. Well, not cancel. I can take out this one, but not this one. This is 2
Okay.
because the exponent here is 1. The power here is 1. So you cannot take it out. Okay, you can rewrite this as 16 1/3 over 4 1/5. They do not have the same base, but I can rewrite 16 as 4 to the square. Now, very quickly, tell me how much, sorry, 1, it's a 3 here. Very quickly, tell me how much is 2 times 1/3? 2/3, right? Over 4 and 1/5. They have the same base, so I copy the base and I subtract the exponents. Tell me, how much is 2/3 minus 1/5? Hello, how much is 2/3 minus 1/5?
7 over 15.
Okay, so that means that I can rewrite this as the 15 root of 4 to the 7. If I want to simplify this a little bit more, I can rewrite it as 2 to the square to 7. 2 to the square is 4. As a final answer, I can write as the 15 root of 2 to the power of 14. Okay, and this will be my final answer, this one. And we're gonna leave it there. We're gonna see each other tomorrow. The link to this class, you will find it in Recursos de la Clase. And tomorrow we are going to begin with our next lesson. Have a nice afternoon. Remember that
Bye,
you have
Miss.
the last hour.
Okay, bye.
Bye. Take care.
Bye, Miss.
Bye-bye.